Oh, look at that. We're live.
Great.
We're just going to give everyone a couple of minutes to join in. I know the link for the event was updated a few moments ago, so we'll just give everyone a chance to get settled. Happy Wednesday, wherever you are in the world. I hope it's a good midweek. So excited to have you join us for the kickoff of this session. So we have our speaker lined up, and we're just going to give everyone, again, just a couple extra minutes just to get settled and connected. How are you feeling, Jason?
Good.
Great.
Good. Ready.
So it is 1:02. We'll just give everyone just an extra 1 or 2 minutes.
Okay. Sounds good.
Great. I see the participant number going up a little bit more, so we'll just we'll wait around and get started, maybe at 1:04 or 1:05. Hello, welcome everyone. I hope you're well settled in front of your computer. You have a good cup of coffee, a glass of water, whatever you need to get through this first session. Great. Oh, the number keeps going up. Hi, everyone. Thanks for joining in.
Excellent.
Fabulous. Okay, so Jason, do you wanna get us started officially? We already have 80 something people in the link.
Great. All right. So take us to the first slide. You want me to?
Yes, please.
All right.
Well, a quick introduction. First of all, thank you so much for joining, spending this hour of the day with us. I see already people chatting us and saying hello and introducing themselves, so it's great. The course will take place over 4 weeks, so we're going to be meeting once a week for 1 hour, where you'll hear from different panelists, speakers, leaders in the industries, colleagues and peers to tackle this big topic around neuro-machine translation and AI and how it's shaping the industry of translation. So what we'll cover during these 4 weeks, we're going to first of all get started with a brief history of machine translations. That's why we have Jason on the call here. Very excited for him to lead this panel. The second week, we'll look at practical uses and benefits of AI translation. That will be co-hosted by our dear friend Betty Cohen, who's a leading translation expert and a member of OTSIAC as well. On the third week, we'll look at ways to successfully implement AI translation. You'll be hearing from a translator. So Kate will be there and will walk us through how they were able in her team to implement AI efficiently for their translation team. And then we'll close off the course with hands-on applications of AI. So how do we actually use AI in our day-to-day as translators? Jason, you can move on to the next. Great. So without further ado, I will let our instructor today. So Jason, I'll let you do a quick introduction and I will follow suit.
Right. Sounds good. Thank you for that course introduction. My name is Jason Cox. I'm product manager at Alexa Translations. So I've been working in software for almost 2 decades now. And I've been in machine translation for almost the last 10 years. And so 10 years in machine translation is a long time. It was a very different world 10 years ago, and I'm going to show you some of that today. Although I am not a language translator, my specialty throughout my career has been translating from technology to business and back. And so I'm hoping I can use that to give you all an overall summary of where we came from with AI and how it applies to machine translation.
Great. Thank you so much, Jason. I'm always quite taken aback by your resume. I'm very excited for you to talk on this topic. So my name is Lucia. I will be the moderator today. I'm a graduate with a communications degree. I've always worked in media, communications, and PR. And the last couple of years, I've shifted into a business development role. I love words and language, and I love building synergies between different businesses. And that's why I'm very excited to be part of the team at Alexa. One thing that I will mention is that we encourage questions throughout the presentation. So that's why I'm here today. I'll be moderating the question space. So if you're joining us on Zoom, there's a little icon right at the bottom of your screen. You'll see a Q&A section. So don't be shy. If you have any questions, just write them down in that section, and I will bring it up to our speaker today, so to Jason. Great. So you can move on to the next. Great. So what will we be tackling today? So the first thing that we'll get started on is the evolution of machine translation. So as Jason said, industry that moves very, very quickly, technology that evolves at a fast pace. So we'll start taking a look behind before we can take a look forward. We'll also talk about the different types of machine translation. We'll really dive into what is AI. We talk a lot about artificial intelligence, but what does it truly entail? Then we'll talk about how Alexa AI ZenMT is trained. We'll look also at how to improve the quality of MT. Also, we'll dive into a topic that is quite sensitive and has a lot of buzz recently, so security and confidentiality. And we'll close off the session today on how to choose the right MT for you. So there's a couple of questions that we want you to ask yourself before you choose an MT platform or tool. And we hope that it will guide you into discovering your MT tool. So Jason, I'll let you take it away, and we can get started.
Great, thank you.
Thanks.
All right, so I'm going to try to fit everything in and leave enough time for questions. So I'll leave just a brief pause at the end of each slide, since I know this material can get a little bit dense. But as you can see, with the dates in front of you, machine translation starts well before the age of computers, and generally well before the time period when people would think of machine translation. But it all starts from code-breaking techniques. And those code-breaking techniques led to a situation where people that did not speak a particular language were deciphering that language. And this was for the purposes of securing the communication. However, the technology proved to be the foundation of what we know as machine translation. So at this time, there's a memorandum on translation here, 1949. That's very interesting if you go and look it up. It's a public paper at this point, and it's just very interesting to see how someone would outline how a machine translation system would work without computers being present at that time. So at this time, ciphers were done at the individual letter level. And then a correction technique was applied to that to add the missing letters. So if you can imagine equating one language to another purely on the letter level, there is a lot of problems with that method. But the groundbreaking aspect of it was that the conclusion was that if a non-language speaking person could translate some text using a cipher, then the machine could also do that work. And it supports the abstract idea that all human languages are using the same vocal organs and the same brains, the same general order of potential complexity. So in other words, languages developed by humans can be translated by machines. And so machines can be taught the general components of what makes up a human language and follow those patterns. Of course, as you're probably all familiar with, in the early days of machine translation, even though the job was done, it was not done to a level that it made it especially useful in the translation industry. That's changed, and I'll walk you through why. This middle column here for I'll be walking through these three major pillars of technology. The first one is rule-based machine translation. The second one is statistical machine translation. The third one is neural machine translation. Don't worry about that too much. I'll cover it more on the next slide. But the overall timeline, so at the first stage, all the way up into the 1980s, we have this sort of cipher based approach. And then in statistical machine translation, we move from a letter to letter based cipher to a word to word based approach, which has a lot more advantages, but of course could only be applied with technology. And then as that continues to evolve, what's better than words is phrases. And so if you can have phrases be statistically significant, then you're going to get larger chunks of your translation that are logical. And so that phrase-based statistical machine translation is what everyone would have been familiar with using the internet in the 90s and encountering translation at that time. So the evolution of that is to a neural based machine translation. And so while statistical machine translation programmers were identifying 16 or less sometimes different parameters and connections between the data to instruct the machine to focus on, the neural machine translation system is able to determine its own connections and therefore determine hundreds and hundreds of parameters for connecting the data and millions of ways in which the data connects. So it's the order of magnitude of connections between the data is a massive difference. And so I'll give you just a super high level overview of some of this technology that's at play. But basically, when neural machine translation came out, it was very much an encoder-decoder based architecture. And so the initial method was to encode the data, in this case text, by turning a whole sentence into a vector. You could think of a vector as a list of numbers or a matrix of numbers. So a very large number. And so the problems with that method are that very large sentences don't convert well into a vector and become oversimplified, and they can introduce problems. Therefore, for very long sentences, a mechanism was developed called an attention mechanism. And that was introduced to allow the engine to focus on specific parts of longer sentences in order to get those parts to be fluent and then match them into the whole. It's very similar to the way that a human listens to a very long sentence and starts to parse it into parts. And so the machine translation engines are doing the same thing. And moreover, that particular technology proved to be even more important, such that now there are purely attention-based mechanisms, attention-based models based on that mechanism. And so that's often called the transformer model, if you've heard of it. And so it represents a way, a large step forward in machine translation. So that's sort of a brief from the distant past to today. Now I'll go into these different types just a little bit more so that you have a picture of what they do. And so rule-based machine translation, it combines the use of dictionaries and a set of fixed linguistic rules to attempt to deliver a translated output. So you can tell that the amount of work that you do on those rules has a direct correlation to the result that you get. So it requires a very large amount of effort to attempt to do that. And anyone who's familiar with multiple languages will know that there aren't necessarily rules that cover all situations. There are exceptions in almost every rule. Therefore, all of those sort of situations were not able to be handled in rule-based machine translation.
Like we say in
However,
French, the exception makes the rule.
yes, exactly. It's you know that it's there. It's built in.
Yeah.
And so these systems are limited, unbendable, meaning that the way that they're programmed from the beginning is how they behave. They're very deterministic. They give you a specific output based upon what they've been instructed to do. That said, this approach is still useful for translating texts that have very specific expected results, such as dates, numbers, currencies, percentages, other formulaic texts that have a number or that have a person and a place, or anything that's translated in a very formulaic way. Rule-based machine translation can still be helpful there because it's going to ensure consistency in that behavior. So that's why we still talk about it and why it's still part of this architecture. But statistical machine translation, as I was mentioning before, this is where the most statistically common translation is delivered based upon either a word or phrase, depending on the system, and based upon its presence in the training data. Therefore, with statistical machine translation, more training data is almost always considered better. This is because of the very nature of the statistical model, which ignores noise that does not occur a statistically significant amount of times. Which means if you have a bunch of examples of a way that something is translated and one error mixed in, it's not especially, SMT is not very vulnerable to that because it's going to focus on the weighted, more common data. The most common criticism of the output of the statistical machine translation engines is that the translation itself sounds mechanical in many cases. It often retains the structure of the original language, meaning if you translate English to French with the statistical machine translation engine, the French will sound more like an Anglophone, the way that the sentence itself is structured. This is because of the direct word and phrase relationship between the two. So now to neural machine translation. Well, actually, before I do that, why we even talk about statistical machine translation, why it's not disappeared into the past, is because it still has a role to play especially in a variety of different situations, but especially in situations where there is no context. So this is where you want the most statistically significant result, and where you don't want the engine to try to fit it into more of a sentence sounding structure. If you are translating a single word that's a heading in your document, you don't want that to turn into a sort of a sentence. Like it may not be fluent in how it's said, but that's correct. It's for the document as a heading, or as in columns in a table, any kind of thing like that. So statistical machine translation still has a role to play, but NMT, this last column here, that's really the star of the show these days, and it's doing the lion's share of the work. And so this technology is the result of applying AI, machine learning, and ultimately deep learning into the world of machine translation. We'll discuss deep learning on a future slide on here. But this is where the engine starts to detect the meaning of the words in the translation and find a translation that is a better language match, even if it may not be a direct translation. There are a lot of mechanisms for this, and it's a very deep topic if you want to investigate it. Look up things like word clustering, and you can find very interesting things about this aspect of neural machine translation. But suffice to say, it's able to find equivalencies that are not direct translations, which is a very important piece of technology for delivering a fluent result. And so this neural machine translation itself and the associated systems that it's built on have received a lot of attention since 2016, and there's no going back at this point. And so it's simply the best possible system that we have right now for delivering fluent translations on long and complicated sentences.
Thank you, Jason. I know
Yeah.
we're breezing through all this great content, and it's every single time we talk about machine translation, I'm quite surprised that we start our journey back in 1949. It's always surprising. There aren't any questions from the audience just yet, but one thing that I wanted to ask you, so if I put myself in the shoes of an audience member here today, someone who works routinely on a day-to-day with language tools, what would they be familiar with then? Would it be the NMT technology or the type of machine translation?
Yes, exactly. 2016 forward, it was widely adopted across the industry. And so prior to that, you would, and during that transition, of course, there was, it took until 2018 or so until everyone was fully up to speed on that. But yeah, prior to 2016, you're most certainly seeing statistical machine translation, and then post 2016 to 18, you'll be looking at neural.
Great, thanks.
Thank you. All right, let's learn a little bit more about AI in general. And so we've been talking so far about applying AI to machine translation, but really it can be applied to many different problems. And so the foundation of it is a technology to allow machine to understand, think, solve problems like a human. And so that all depends upon what you train it to do. So most of us are familiar with AI on a daily basis in one form or another these days, from more subtle forms such as face and voice recognition to self-driving cars and predictive marketing, these kinds of things. The topic that we'll be talking about specifically today is called natural language processing. It is a chapter within that artificial intelligence. So artificial intelligence, as I said, is the foundation of this. You can see this diagram. Then within that, machine learning is a specific type of artificial intelligence, allows computers to handle new situations that they haven't encountered before, that are similar to the data in their training. Enables the machines to improve at tasks with experience. And then a very important part about this machine learning component is forgetting. And so forgetting is very important, and it's something that we don't always think about as a person. But if you've learned something that's incorrect, you need to be able to forget it. If you learn something that contradicts it, and you find that your previous knowledge was incorrect. So much in that same way, the machine translation system also needs to learn how to forget. And this is a way to sort of fix the holes that I was mentioning earlier, as far as having a neural machine translation system learn off of data that's not necessarily all correct. And so if it encounters something that is outweighed by many other previous examples, there has to be a threshold and a mechanism for forgetting. So that happens in this machine learning sphere. And then there is deep learning on top of that. And so deep learning is a specific form of machine learning where artificial intelligence is used to classify and order information, particularly unlabeled, unstructured data. And so translation data, language in text in one language, text in another language that are equivalent, are a very good example of that unlabeled and unstructured data. And so this deep learning is a way to make sense, make connections between data that would be otherwise very difficult to make connections between, like translation data. It can also be applied, as I mentioned, to many, many other industries, and it has and continues to be. And you will see more and more of this in the future. Anything that you can think of that you can collect data on, you can build a machine learning model on.
That's exciting. Thank you, Jason. Again, just a reminder for our participants, if you have any questions, if you want us to dive a bit deeper into any topic, just don't be shy, use our Q&A section. Jason, if I may, maybe what does it take for something to be truly AI? Because I feel in this day and age, we often hear the abbreviation AI and we think something might be artificial intelligence, but what is the defining factor of an AI technology?
A good question. I guess there's a lot of different ways to define it, sort of depending on the scope that you're working in. But in the case of machine translation, I think that the key factor is the ability for the machine itself to be the one determining what's important and how the two languages connect. So that's a fundamental shift from where the programmers were defining with the help of linguists and translators to determine how these things connect. In a neural machine translation system, the system itself is making all of those sort of connections. And so it's able to make and use connections that would not necessarily be logical to a person, even a translator with a lot of experience. And that's just because of being able to the power of machines at this time and being able to iterate over that data millions and millions of times. It's just not something that a human has the sort of time bandwidth to do. And so that's my opinion as far as where the line is on AI for machine translation. Of course, it applies to other things that
Interesting. Well, thanks for humoring my question.
Thank you for asking. All right, so we'll go on. And so we'll talk a little bit, I'll talk a little bit here about how we're using it to give you sort of a practical example for some of this. And so at Alexa, we use a neural machine translation engine in addition to an ecosystem of other machines and systems that work together to deliver the translation result. However, I can give you a little bit of information here about how we've used this particular piece of technology. And so this is based on, as I was mentioning, the amount of parameters involved in a neural network. In our particular case, it's on the order of tens of millions of parameters. And so if you were to think about writing down those parameters, it's a life's work at best. And so on top of that, so that's the network itself and how it's programmed. On top of that, the most important thing that you can do for a neural machine translation system is give it lots and lots of great data. The more specific that you can get with your data in terms of region, in terms of subject matter, in terms of company, in terms of translators, the more specific that you can get, the more consistent and useful your result will be, and the more that it will sound like the translators that wrote the training data. And so this is a very important aspect. It's not necessarily a more is better situation. There is a certain threshold that you have to hit in order to achieve certain quality. However, giving a system all of the language data in the world doesn't help it, in the sense that you get farther and farther from something specific and tailored and closer to something generic and common. So if you are talking about some extremely broad and statistically common subject matter, then it might serve you. But if not, then you'll be better served by a model that is more closely tuned to your specific situation, whatever it is that you're wanting to accomplish with it.
This is it's great, Jason, and I think it really captures a great vantage point for our audience, looking at how we do it on our side. Just looking at the chat here, we have a couple of questions. One question from Arnella is, do you think that AI will take over the translation industry in the future, and so that translators won't be needed anymore? Very controversial question, Arnella. Something that we can dive in later on in the presentation. But Jason, I will let you maybe attempt an answer here.
Yes, this one is easy. No, would be the answer. I don't think so. I don't think that, I mean, although this is a fundamental tool, and I think that it will be broadly, continue to be broadly adopted in the translation industry, but it is a tool. And so the translators have a very critical role to play. They not only are the users of this tool, but they are also the ones that power it. And so the information that this engine is using and will always use in the future when you're training these tailored models always relies on subject matter experts in your specific area. So
Thanks.
Translators have a lot to do still. And they still certify the end translation. So whether they typed everything from scratch or used a machine translation tool in the process, they are still responsible for the end result. And I think that that's something that the industry will consider to continue to see as a desirable thing.
I know it's something that we can discuss for hours on end, but right. If I just may add, Jason, something that is also clear from research, from data in the industry, from a consensus within the experts, is that the translator is at the heart of the process. It's no longer a human in the loop. It really is a system that is built around the translator. And so, as Jason said, the role will be evolving, and the actual work that the translators are doing will be changing and evolving, like in any other profession, of course, but it will be always necessary. A question from Judy, Jason, is how are we different from DeepL, and what is the ecosystem of machines that we're talking about? I think it was referring to what is truly AI.
Yeah, for sure. And so DeepL is another example of a neural machine translation system. And they came into prominence at the same sort of time that I've been talking about here. And it was an evolution from essentially dictionary software. So DeepL has a lot of expertise in the European market. It is an example of a slightly more broad system. So I'm not a DeepL expert or anything, but yes, they are an example of another neural machine translation system. And then what is the ecosystem of machines that you're talking about? I'll talk about that a little bit more with a picture, but suffice to say, the way I was describing machine learning and different systems for that outside of machine translation, you can also use it for little aspects inside of machine translation, quality assessment mechanisms, post-editing mechanisms, pre-processing and post-processing. There are a lot of different additional machines that you can insert into the process, and things that allow the translation to flow through a different path and get you to the best possible result. for your situation. So that could be a machine that is analyzing the incoming translations for context and determining what sort of subject matter this particular sentence is. Could be a mechanism for looking at what subject matter a paragraph is, or a page, or a document. And all of these things can be applied at different levels, depending on the sort of result that you're trying to get.
Great, thanks, Jason. And like you said, an image is worth 1,000 words.
Yeah.
So maybe we can move on. And there are a couple of questions as well. So as I keep moderating, I will just raise them up to your attention.
Okay. Want to keep going?
Yeah, sure. Go for it.
Okay. And so a little bit more information about how to improve the quality of machine translation. And so the first ones are ways that you can improve the underlying engine. And so those are pre-processing, post-processing, and retraining. So pre-processing meaning, as I was mentioning, for neural machine translation systems, clean data is very, very important. If you are translating a chat between two different people, it's very important that you fix the spelling mistakes in the original text in order to do the translation. Otherwise, you'll be missing certain words. So there's pre-processing, and there's also post-processing to run a bunch of checks to make sure that you're getting the results that you want at the end of the machine translation process. Since, as I mentioned, lots of different components are used. And with the nature of neural machine translation that you will get, it's very difficult to only get one result out of a system like that, because it's found so many different ways the data connects. And so if there is a specific result that you're trying to enforce, for example, a certain punctuation rule, a non-breaking space in a certain place, a number format, something like that, then it's good to do that either with rule-based machine translation, or if that thing is built, that piece of text is within a sentence that it needs to be fluently translated, then post-process to find and fix that format of that date if it was broken, or other number, or any other kind of content. So, and then of course, retraining the neural machines. So not only the core neural machine translation system that we've been talking about a lot, but also those sort of ancillary systems that work in that ecosystem. So you, just at the same way that you have to retrain the central engine, you also have to retrain the mechanism that is used for assessing quality or making replacements, finding terms, all of those sort of tasks. So that's sort of the underlying engine component at the top here. And then on top of that, there's user-driven customization. And so this comes in a variety of different forms, but there's providing, there's a sort of a feedback cycle where a linguist and translator kind of a reviser environment where you take some sample documents, run them through machine translation, and then analyze the result, and from that, put together a variety of different adjustments for the model. This is something that happens very early on in a system usually, but it is very important for that customization aspect. This is where you really zero in on the needs of a specific company. There's also using collateral, previous translated data from a specific client. In this case, I've got term-based and translation memory data listed here. It could also be use of precedent documents. There's also training for fully custom neural machine translation for an engine for a specific situation. There's also an adaptive machine translation system that works sort of between these models. And so it sits on top of the neural machine translation layer, and it's taking real-time feedback. So in order to adjust the engine, at the time of editing, so that future segments, even a few seconds later, will be informed by the translation that was just edited. And those translations are placed in a position in the engine so that they are sort of like prioritized training data. And they are used to emphasize certain results. And then after a certain period of time and after a certain number of edits occur, and these parameters have to be tuned for specific situations, but after that threshold is reached, then this data is moved to a separate pipeline where it's used in more of a complete training method. And that is to avoid lots of minor adjustments done to that layer becoming too important and becoming overemphasized in the translation. And so
that's great, Jason. It's the next frontier looks like a adaptive NMT.
Yes.
Question
good way good way to sit in between that spot before your full engine retraining, yeah. But more advanced than a term-based or translation memory.
Oh, that's great. One question from our attendees is around bias from AI. So a question that he has was, we've seen in the news recently that the risk of AI not being objective, for example, doctors being referred to as male, while nurses being referred to as female by AI technology. Is there a way to address this in the translation industry, and how do we account for that bias while we're training an engine, for example?
Yeah, for sure. And so part of this comes from, I mean, the best possible way to solve this is with robust data. If you have robust data that has the presence of all possible gender options, as in this example, or occupation to name relationships, those sort of things, if you have enough of that in your data, then that will solve it. Okay. And so a neural machine translation system itself is quite good at saying, if you give it a proper noun, and then later in the sentence refer to a sort of pronoun, it will apply the appropriate gender to it. But there are ambiguous connections sometimes there between names and genders, so it could still be wrong. And in those sort of situations, or if you have the situation where your data itself is hugely biased in one direction or another, you can augment that data with synthetic training data. And so imagine if you formulaically took a variety of different texts that have a male name and are referring to some sort of doctor activity, and you replaced in those situations the pronouns and names, and provided that to the neural machine translation engine as training data, then you would be emphasizing that and giving that as an option, and the machine would use that. You could even take that as far as you want to bias it a different direction if you wanted it to be biased in a certain direction.
That's great. Thanks, Jason. I know that we only have 15 minutes left. I know it's hard to believe. One thing that I will maybe bring to your attention is a question from Eric, one of our attendees. He was wondering, so Alexa, our platform is available in English, French, and Spanish. He was wondering, is it the same database and system for all the combinations of languages, or are we separating all of that based on language combinations? I think this is a question to shine a light maybe a bit more on how we structure everything, and I'll leave it up to you, Jason.
Yeah, and so I think that brings us, it's a good segue. It's a good segue. Yes. And so they are in the same, they're in the same ecosystem, but they're very much different engines. They are very much different databases, and the ancillary components that I mentioned that are performing other tasks alongside machine translation or with it are also trained separately. And so there is, you get a little bit of economy reversing one language, but even still, work has to be done. So even the English, French, and French English models and databases are completely separate, and unfortunately have to use different methodologies. But that said, there is learning that you can apply across them in terms of infrastructure, in terms of availability, those sort of aspects, the servers that get spun up under certain conditions, all of those sort of technological aspects are the same.
That's great, Jason. One thing that our participant is asking is, do we think AI will expand in the next few years and be able to handle live interpretation as well? We can also give a bit of breaking news here for the people that joined the call, but I'll let you take the answer first.
All right. And so I do anticipate that it will continue to expand. There's been a lot of improvements, even in just the last 2 or 3 years. Different technologies have become available. Computers continue to get more powerful, and particularly of importance to this discussion, graphics cards, graphics processors have taken leaps and bounds in performance in the last years, and I anticipate they will continue to do so. There's a little bit of a plateau there as we hit sort of actual chip circuitry limitations and things like that, but I expect that we will continue to get a lot more power out of the current technology. That power will be used for lots of different AI tasks, and one of those is definitely machine translation.
Great. So I'll let you continue with the presentation, Jason. I'll continue to filter the questions and bring them to your attention as we move along.
Okay, and I can talk more about the live interpretation part.
Oh,
but...
I know.
Okay.
And it's also something. I mean, the industry is moving and adapting very quickly as the business needs are growing, and our team is actually working on this as well. So it's something that we were looking to offer as part of our complete business offering in the next couple of years. Yeah, for sure.
Exactly. And this is, as I mentioned, the other types of other types of artificial intelligence. One of the prominent ones is voice recognition. And I think any users of voice recognition will have noticed that it's improved quite a lot in the last years as well, and is becoming a more viable technology.
Great.
Okay. So we've got 11 minutes. I don't want to take all of it. But suffice to say, this is a simplified diagram, but the idea is that you have inputs as text, as documents. You have training data that trains this machine translation engine. It has a lot of different components, as I've sort of discussed briefly as we've been going through different things. These different things are listed here in a sort of simplistic way. However, they are all interwoven in this sort of ecosystem. Rule-based machine translation, of course, providing that role of finding and replacing things. If, for example, a translation memory match is a really great example of a very simple rule-based machine translation replacement. But there's lots of others. There's lots of formatting rules. There's lots of things like that. Suffice to say, all of this adds up to the translation output, and this is the way that that our system works. The document is originally segmented and then translated, and then the translations can be edited in the editor, and then the output can be generated in its original format, so that all of the original formatting of that document is maintained to make the process of delivering that translated document faster.
I know it looks so easy when people go into our platform and they just hit translate, but this is what actually happens behind the scene, all of these steps.
Yes, okay. And then, okay, so security and confidentiality, I'll try to go quickly here. And so the Alexa translations system, another one of the key differentiators here is that it was built from the ground up with security in mind. And so our customer base has always been in the security and confidentiality conscious environment. And so as you can see here, I won't read you all these points, but it's very important that when you're looking at a machine translation system and security and confidentiality is important to you, it's very important that your data is kept somewhere entirely separate from other clients, that access is strongly and strictly controlled, that there's encryption and at rest and while the files are being transferred. It's very important that the text itself is not saved and used for other purposes or used to train an engine for a different client. And it's also important that after you request that data is deleted, that data is really deleted. And so in our particular case, that data is stored on a sort of a virtual disk instead of a physical disk, which makes retrieving that data even harder. And then also those individual disk sectors are set to write only after the delete occurs and then prioritized for rewriting. Anyone who's ever used had to recover deleted files from a hard disk will know that files are not really gone when they're just deleted. They're only gone when the sectors have been sufficiently overwritten so that nothing can be retrieved. So on top of that, we have antivirus, network and vulnerability scanning, penetration tests. We are SOC 2 certified, which is a outside auditing firm confirming all of these things. Our systems itself isn't vulnerable to these things, but from a perspective of protecting the client, it's still worth running all of these checks. So.
For sure, and I think it's a great segue into how or what clients should have in mind when they're looking for NMT solution. So we put together a quick list of questions just to help you guide through this process. So a few key things that you want to start looking at when you're shopping for your new NMT partner. Things like what languages do you work with, regions, or even topics. So as Jason was describing, the more precise you can get, the better results you will have. How many words will you be translating? So will you be using MT for only a few projects or to help with the load of projects that you have? Another thing that is important to ask yourself is what kind of past translation data do you have? So are you counting on years of translation? Further to the question that Eric from our group just raised, what language pairs do you already have? And are you a good candidate for a dedicated NMT, for example? Another question that you would want to ask is, will you need API integration with existing tools? For example, do you have a translation management system that you love and you want to make sure that your MT is able to integrate? You also want to be very clear on what types of games you're looking for. So why are you incorporating MT? Is it to rely less on revisers? Is it because you're lacking translators? You have to really think about what are the efficiencies that you're looking for there. And the last thing is, what is the goal in implementing MT? So again, just thinking, what is the end goal with this technology? Further to the slide that we saw before, another question that we could ask is, how confidential is your information? So do you really know who you're getting in bed with for MT and what they're doing with your data? That's something very, very important. I will maybe just move on to a short Q&A session. I saw that we still have plenty of questions in the chat, so maybe we can get started on finishing, actually finish answering those. A question that I see here from Judy is, do you think companies will have to create new positions for people who will maintain NMT used within a company? So how do we see new opportunities and new jobs or job expansions within the NMT business? I know that we also have Gary on the line. So Gary Killassi, our CEO. So feel free to jump in, Gary, at any point if you want to answer a question or provide any guidance. You're more than welcome to.
Lucia, you know I would never miss the opportunity to jump in. So and I will. I actually love Judy's question. It will in fact open jobs, and it already has. I'll give a parallel that we are already familiar with. You've all seen all kinds of other tools be used. So I'll use the example of a CRM, for example. So CRM, large organizations will have it to keep track of their clients or of their users, etc. And large organizations will have somebody in charge of managing the CRM, sometimes multiple people, just to keep the data there clean. So the effects of it but even to actually train the people internally to use it effectively. Large tools, when you implement internal tools, require somebody to sort of be in charge of it. If it's not a significant tool, sometimes it could be a part-time role, but to the extent it's significant, and NeuroMachine will certainly help with workflow, it will, and the larger the organization is, the more it means you have at least one full-time person on this, and sometimes multiple to actually keep it. So it'll open all kinds of new jobs. It really also ties into some of the other questions that were coming in, because Yekaterina had a question saying, well, we know AI struggles with hidden meanings and wordplay, and there was a question about creative translation. And AI is getting better at those things, but you're right. I mean, and that's the whole point of why translators are so critical is this is a tool in your arsenal. You keep training it, but ultimately you are the final say. And it's really the feedback loop here is important, because the more you give to the tool, the more it'll adapt to your style, which ideally saves you more and more time as time goes on. But also to some of the questions that there was a question, I think it was also Judy earlier, around sort of comparison to DeepL and so on. What was great about DeepL is that up until DeepL came along sort of broadly, Google was sort of known as the machine translation, and it was almost synonymous that people thought of machine translation and we're like, oh yeah, Google, like I Google Translate things. So it actually provided a good alternative, and it proved how important data was in training. And they used a lot of sort of the European Union high quality data for the training, and then you saw the big jumps in quality. So that was actually, you got to give them credit for sort of proving something that it is critical. It's not just having big data, having high quality data is very important. Beyond that, and we sort of followed similar strategies when it came to high quality data, but focused in our local marketplace, focusing on Canada and the region. You never have sort of a magic wand to see everyone's back end, and it's really everyone invests in their own strategies. What we do is comparisons at any given time to other tools to make sure in the language we are offering, you are sort of leading edge and consistently above it. But I must say, for any of you that are part of large organizations or have your own translation organizations, investing in training it properly with your own data is going to be the next frontier, because good NMT out of the box is a good solution, but you taking it to the next level with your training and some of this employees we just talked about and the new roles that were done, it's really what's going to really build that gap and make your team's life easier when you have those. I'm preaching to the converted with the current audience, a lot of translators, impossible deadlines, really pushing against the clock sometimes with internal clients. And sometimes AI will be your best friend, because the only way to get some of these things done sometimes is if you're using AI effectively. And I'll leave you with one last thought. You've all used Excel in one form or another, but I've seen people that use Excel to its fullest and will use their formulas and make the most out of a tool in a way that I never could. And I see people on Excel that just put in the numbers so they could get an addition at the end of it. So it's like that with NMT as well. You can make the most out of it, or you could just use it to get a sum at the end of it.
It's always Thank you, Gary. Always a treat to hear you on the topic, and then you have very insightful comments. Jason, I don't know if you want to move on to the next slide. It will give everyone just a bit of a preview, a tease of what's to come next week. We will be talking about the benefits of AI machine translation, evaluation methods, and looking at case studies. Your instructor will be Betty Cohen, very well-known figure of the translation industry. So I will maybe just address this one last question from Robert in the chat. So Robert is asking if we can train Alexa AI to use an organization's specific terminology and sentence structure. Very much so, Robert. So as Gary alluded to, it's actually what we recommend. If the client is a good candidate for that, that's something that we always preach, and that's the best way to get even better results. So thanks again, everyone, for joining in. Very excited to finally kick off the course today. We look forward to seeing you in the next 3 weeks, where we'll be talking everything and anything AI. Don't be shy if you want to share this on social media. Not too late for everyone to start joining in. Registration is still open. Have a lovely afternoon, end of your day, wherever you are in the world. And thanks again for your time. Bye, everyone.
Thank you, everyone.